He wasn't a general. He wasn't a politician. He wasn't even an engineer with a fancy degree. He was a welder. A man who spent more time under the hiss and crackle of hot steel than behind any drawing board. And yet, in the darkest years of the war, when the world trembled under the weight of total conflict, this man's rejected idea would do something the best minds of the war machine had failed to do. It would change everything. In 1940, when the world seemed to be unraveling one battlefield at a time, military leaders faced a brutal truth. Armies needed guns, not in hundreds or thousands but in millions. Every rifle, every machine gun, every piece of metal counted, but manufacturing was slow. Precision machining ate up time, money, and manpower. Traditional weapons required hours of skilled labor, delicate tooling, and machining tolerances that simply couldn't keep up with the speed of war. Factories were already pushing their limits, workers were exhausted, and the enemy wasn't waiting. The war was accelerating faster than the assembly lines could spin. Nations needed a miracle, not from laboratories or war rooms, but from somewhere unexpected. And that's when a welder, a man with a reputation for being a little too bold, stepped forward with an idea that seemed so crude, so embarrassingly simple, that the experts laughed. To them, it wasn't a weapon. It was a pipe with delusions of grandeur. They called it a plumber's nightmare, but history would call it something else. What this man had designed was not elegant. It was not polished. It didn't carry the intimidating silhouette of a traditional weapon, but it could be built fast. Very fast. It could be made by unskilled workers. It didn't need expensive machinery. It was, quite literally, a gun made out of stamped metal and welding. And that was exactly what the war needed. Factories that once took days to make a single complex firearm could now produce dozens in a single shift. The weapon, ugly to some, beautiful to those who understood its purpose, became a silent hero of industrial warfare. But the journey from rejection to revolution wasn't smooth. When the welder first presented his design to the military brass, they smirked. They dismissed him. They called the design too crude and too unreliable. To them, a weapon was supposed to look like a weapon, heavy, elegant, engineered with surgical precision. But war doesn't reward elegance. It rewards speed, scale, and utility. The welder didn't quit. He took the rejection not as an end, but as a challenge. He went back to his workshop, working through the night, refining the design not to make it prettier, but to make it even simpler. Every component was stripped down. Every unnecessary part was eliminated. His philosophy was clear: if you can remove it without breaking the function, you should. And soon, he had something that didn't just work. It worked perfectly for what the war demanded. As the conflict spread, supply lines strained. Nations facing massive military buildup realized that traditional weapons manufacturing couldn't keep pace with demand. Skilled machinists were being drafted. Precision steel was being rationed. But this weapon didn't need those things. It could be made almost anywhere, in small workshops, car factories, even bicycle plants. This was a revolution hiding in plain sight. When the weapon was finally reconsidered, not because of admiration but because of desperation, it stunned everyone with its brutal efficiency. One skilled machinist could make a single complex firearm in 20 hours. But this gun, it could be assembled by a team of untrained workers in less than one, and it worked well enough to arm soldiers, resistance fighters, and entire battalions. The mad welder, once laughed out of the room, was suddenly the man who had given the war machine a breathing space it didn't know it needed. The numbers tell the story better than words ever could. Millions of these weapons were produced, each one saving time, steel, and manpower that could be used elsewhere. By the end of the war, experts estimated that this single, rejected, design had saved 50 million man-hours. 50 million. That's the difference between struggling to catch up and overwhelming the enemy with sheer output. But it wasn't just about numbers. This gun had a psychological weight. It symbolized something deeply powerful: that ingenuity doesn't always come from the top. That sometimes the greatest solutions are born in places where no one is looking. As the Allied war effort surged, resistance groups across Europe found themselves holding a weapon that was cheap, disposable, but utterly reliable in close combat. It could be smuggled, dropped from planes, and hidden in barns. It didn't require training. It didn't require precision care. It just worked. Behind enemy lines, ordinary people, farmers, teachers, workers, held in their hands a weapon born from one man's refusal to accept. No, it was their equalizer. This wasn't a designer gun. It wasn't built for beauty or prestige. It was built for war, built to give people a fighting chance, and it delivered. What makes this story so extraordinary isn't just the weapon itself, though its impact is undeniable. It's the way it came to life. One man, One idea, rejected then accepted not because it was perfect, but because it was unstoppable. War has a way of revealing truths that peacetime hides. And one of those truths is that innovation often comes from the edges, from the hands of people who build things, who live with the material, who know what works in the real world. This welder was not a visionary in the classic sense. He didn't write manifestos. He didn't give speeches. He just built something that worked when the world needed it most. And as the factories roared, as stamped steel met welded joints, the sound of his idea spread across continents. A crude little weapon born in the shadows became a quiet giant of the war effort. This is the story of how one mad welder changed history, not with a speech, not with a strategy, but with a tool so simple it forced the entire military, industrial complex to rethink what was possible. His rejected gun became a symbol of ruthless practicality, of cutting through the noise to deliver exactly what was needed. And in doing so, it saved time, it saved labor, it saved lives, and this was only the beginning. The gun itself was deceptively unremarkable. It didn't have the sleek profile of high-end military weapons. It wasn't designed to impress generals in parade grounds. It was designed to be made fast, used fast, and if necessary, discarded fast. But hidden inside its simplicity was a design philosophy so brutally efficient that it forced entire industries to adjust their expectations. You see, before this welder's idea was finally accepted, governments were locked in a mindset. The belief that every weapon had to be a masterpiece of precision engineering. The prevailing thought was the more complicated it is, the better it must be. But in total war, perfection is a luxury. Speed and numbers decide outcomes long before elegance enters the picture. When the welder's gun design was finally greenlit, something remarkable happened. Production lines that had once required specialized lathes and milling machines suddenly needed only stamping presses and welding rigs. Instead of months of training, new factory workers could be taught to make these guns in a single day. Men and women who had never touched a firearm component before were now part of the war effort, churning out thousands. This was no longer a military operation alone. It was a people's industry. The weapon wasn't just a tool. It was a statement. It told the world, we don't have to match the enemy's weapons with beauty. We'll beat them with numbers, with speed, with ingenuity. Behind this breakthrough, the welder's original stubbornness echoed through every factory floor. His idea had been designed with one goal in mind: strip everything unnecessary away. No fancy machining. No delicate tolerances. No parts that needed to be babied. Every piece had to be something that could be made cheaply, quickly, and without depending on scarce, skilled labor. That philosophy paid off almost immediately. Production skyrocketed. Where traditional submachine guns took days to manufacture, this new weapon took hours. And because the components were so simple, defects were rare, repairs were easy, and replacement parts were abundant. For soldiers on the front lines, it meant they could rely on steady supplies of weapons without worrying about factory delays. For resistance fighters operating behind enemy lines, it meant they could receive drops of these weapons by the thousands, often with instructions so simple that anyone could learn to use them within minutes. The gun's presence grew quietly but steadily. It was never meant to be the star of the show. It didn't get headlines like the massive bombers or the thundering tanks. But if you followed the supply chains, if you traced the ripple effects of saved hours and resources, you would find its fingerprints everywhere. Every time a factory made this gun instead of a complex alternative, skilled machinists were freed up to make engines, aircraft parts, or artillery. Every hour saved multiplied across thousands of factories. That's how 50 million man-hours were reclaimed, not through one massive invention, but through millions of small, fast, efficient builds. In the war rooms, the tone began to change. The same officers who once dismissed the design as joke began to see reports from the field. Troops were armed faster. Supply bottlenecks were easing. Even commanders who had scoffed at its crude shape now called it indispensable. And yet, behind this weapon's success lay a deeper, more human story. The welder who created it was never fully embraced by the establishment. Even after the design exploded in popularity, he remained a bit of an outsider, a reminder that great ideas don't always come from polished halls. Some come from grimy workshops and stubborn hearts. He never sought glory. He didn't have to. His creation spoke for itself. Resistance fighters especially adored the gun for its simplicity. Parachuted into occupied Europe, these weapons could be dropped in wooden crates and assembled on the spot. Some came with a few dozen rounds. Others were paired with instructions barely longer than a postcard. A gun in the hands of someone willing to fight was worth far more than an over-engineered weapon stuck in a factory queue. And then came the moment that cemented the weapon's place in history. When the Allies prepared for major offensives, they needed not just soldiers, they needed armed populations. Behind enemy lines, resistance networks were desperate for tools that could level the playing field, even slightly. The welder's gun became their answer. Imagine this: small villages where people had never held a military weapon suddenly receiving drops of crates in the dead of night. Inside these crude, stamped steel guns, in minutes they could be ready to fire. No manuals, no training camps, just point and shoot. And for the occupying forces this was a nightmare. They were facing not just soldiers, but entire populations who could now resist. This was the power of industrial simplicity. It didn't just supply armies, it empowered ordinary people. It wasn't long before military strategists realized they had underestimated the weapon, not because of what it could do mechanically, but because of what it could enable. It turned scarcity into abundance. It turned fear into resistance. It turned the tide in places where the enemy had grown complacent. And still, through all this, the weapon's creator remained largely unknown to the public. His name rarely made it into newspapers. There were no parades for him, no statues. But those who worked on the factory floors, those who loaded the crates, those who saw firsthand how fast they could arm entire groups, they knew. They knew the welder had changed the game. Military historians often speak of big machines, tanks, aircraft, battleships. But wars are won not just by what's loudest, but by what's most efficient. And in this war, efficiency was king. Every hour saved on the factory floor meant more planes in the sky, more ammunition in the field, more pressure on the enemy. And behind that invisible equation, this plumber's nightmare quietly carried the war effort forward. Soldiers gave it nicknames, some loved it, some cursed its crude form, but they all respected it, because when they needed a weapon fast, this was the one that showed up. In war, necessity often beats tradition, and what started as a laughingstock had now become a backbone. 50 million man-hours saved. That's not just a number, that's the power of simplicity. It's the difference between endless shortages and unstoppable production. It wasn't about perfection. It was about making something good enough and making it right now. And sometimes, good enough wins wars. War doesn't have patience for perfection. And in the final stretch of the conflict, the welder's once mock creation stood as proof of that. What began as a rough sketch on a workshop table had become a symbol of industrial speed, a physical embodiment of the idea that innovation is not about complexity, but clarity of purpose. By now, the weapon had spread across continents. Its production lines stretched through factories that once made bicycles, cars, and even kitchen appliances. It became the great equalizer of wartime manufacturing. If you could stamp metal and weld, you could make a weapon. In a war that demanded speed over style, this was gold. Soldiers on the front lines spoke about it with a strange mix of amusement and respect. It wasn't pretty. It jammed occasionally. It lacked the intimidating weight of other guns. But it was there. When other supply chains faltered, when higher-end weapons were delayed, this gun showed up in wooden crates by the thousands. Its design was so simple that even when parts were damaged, soldiers could fix it themselves with whatever was at hand. There was no waiting for a specialist. No long repairs. If a part broke, another could be stamped out in minutes. If the barrel wore down, it could be replaced without a machine shop. That flexibility was something traditional design simply couldn't match. And as the war intensified, this mattered more than anyone had predicted. Behind the weapon, the welder remained an enigma. He wasn't a public figure. He didn't give stirring speeches. He wasn't paraded through factories, but his stubbornness had done something remarkable. It had forced military bureaucracies to rethink how they defined value. For decades, weapon design had been about precision, control, and status. Now, they were learning to embrace chaos. Fast, scalable, relentless chaos. The impact was so profound that even enemy intelligence reports acknowledged the scale of production. Their analysts couldn't quite believe how many of these guns were appearing in the field. They assumed at first that the Allies had discovered some revolutionary new factory technology. In a way, they had, not through machines but through an idea. And the idea was simple: make it cheap, make it fast, make it everywhere. This shift didn't just change production, it changed strategy. When commanders planned operations, they could now count on massive surges of weapons flowing in at short notice. A resistance network behind enemy lines could be armed in weeks, not months. Assault units could be reinforced quickly. Frontline shortages shrank. Even in the shadow of tanks, bombers, and massive artillery, this little weapon became the quiet foundation of military mobility. It freed up engineers and machinists to work on the machines of war that truly needed their skills. It amplified manpower by multiplying what ordinary workers could achieve. 50 million man-hours saved. Imagine what that actually means. 50 million hours is the difference between a factory struggling to produce and a nation overwhelming the enemy with production. It's more than 2,000 years worth of labor for one person. It's entire battles fought and won before they even reached the front lines, because supply and logistics shape wars long before soldiers pull the trigger. That's why the gun wasn't just a weapon. It was leverage. It was time. It was pressure. And for the welder, it was vindication. He had spent months being told no. Being told his idea wasn't good enough, wasn't pretty enough, wasn't proper enough. But wars don't care about proper. Wars care about results. And his design had delivered results at a scale no one had expected. Historians would later try to put his work into neat boxes. Cost-effective, efficient, innovative. But those words missed the heart of it. What he did was remind the world that brilliance doesn't always wear a suit. Sometimes, it wears a welding mask. His design became a blueprint for a new kind of thinking in military production. Even after the war ended, industries studied the weapon as a case study in mass manufacturing. Governments realized that future conflicts wouldn't just be won by who had the most advanced technology, but by who could produce fast, cheap, and at scale. This philosophy influenced entire generations of weapons and manufacturing. It showed that the fastest path to victory isn't always through the most sophisticated machine. Sometimes it's through the simplest one. The resistance fighters who held the gun never thought about engineering theory. They didn't care about manufacturing methods. All they knew was this: they had something that worked, something they could rely on, something that made them dangerous. And in a war that tried to crush hope, giving ordinary people power mattered more than anyone could measure. The welder never received the kind of fame others did. His story wasn't splashed on magazine covers, but quietly, among those who understood the weight of what he'd done, his name carried a quiet respect. He wasn't just a man who built a gun. He was a man who taught the world that sometimes the simplest answer is the strongest one. His rejected design had not only armed soldiers and partisans, it had forced an entire war machine to adapt. It had given time back to nations drowning in production schedules. It had tilted the scales in favor of those who believed in doing more with less. And as the war came to an end, the weapon faded from the front lines, but its impact did not. Factories had learned to be faster. Commanders had learned to think differently. And the world had learned to respect the power of the ordinary worker's ingenuity. Innovation, after all, isn't always born in the boardroom. Sometimes it's forged in the spark of a welder's torch. This story isn't just about a gun. It's about the invisible victories that shape history. It's about the people who never make it onto posters or postage stamps but change the world anyway. 50 million man-hours were saved. But in truth, what was saved was something bigger: the ability to fight, to resist, to adapt. One idea, one design, one welder. His weapon might not have been the prettiest on the battlefield, but it was the one that made sure the battlefield could be supplied at all. And in war, that's the kind of weapon that wins.